Hello, welcome again to the course on audio signal processing for music applications. This week we're talking about sound and music description. In the theory lectures we talked about how to analyze sounds and obtain some features based on spectral analysis or on the things that we have been talking all along this course, but specifically to describe large collections of sounds. So the idea of obtaining features with which then you can measure the similarity between sounds, or we can cluster sounds, or we can classify sounds. And we mentioned about Essentia, the software library tool that we're going to be using in this week and also a little bit next week. So let's talk a little bit about Essentia and how to install it and how to use it in some simple examples. Okay, so you can go to the website of Essentia, essentia.upf.edu, and in it you can find a lot of the documentation, where to download it, things that have been done with Essentia, and other related information. So again, Essentia is an open source C++ library that has been developed thinking about audio analysis and audio based music information retrieval. So this idea of describing sounds and music, and it's an open software project. So it's the license is Affero GPL, and it has quite a few things. It has a whole bunch of algorithms and a whole bunch of ways to extract features from sounds, but also you have a whole bunch of utilities that makes that quite easy. So it can facilitate our programming of more complex ways of extracting these features. So for example, this is a block diagram of a series of algorithms that have been put together using these Essentia facilities, and therefore we can easily and efficiently generate these type of descriptors of sounds. It uses Python quite a bit. In fact, it has a good support for Python, for wrapping this C++ library with Python. So we get the benefit of an efficient library, an efficient C++ implementation, and at the same time quite easy and convenient Python framework that can be used to call the C++. So the first thing that we should do is just go to the download page, okay, and it's in GitHub, so you can find the source code in GitHub, and also there is some accompanying software that you might use, which is this Gaia software. It supports Debian and Ubuntu, and also Mac OS X, even though of course in this class we are going to use the Ubuntu version and show examples using Ubuntu. So if we go to the Essentia GitHub page, okay, so here is all the source code of Essentia. That's a pretty large piece of software. So to install it, the normal way when you want to really keep updated on these things and not have to reinstall it every time is to use this clone URL. So we can copy this URL. Okay, and now we go to the terminal. We can go to a specific directory, or well, I guess I have a TMP directory, and I will clone the repository into my machine. So I will type git clone, and I just put the HTTP address of the repository. And now we'll start copying everything into my computer. That may take a little bit because that's quite a large library. So maybe let's just stop it because I already copied. So I will stop it here. Now I will go to the place where I already copy this library. So it's I have here all the structure of what I copied that is in GitHub. Okay, now in order to, we have to compile it and install it. So for that we can go back to the Essentia website, And within documentation, there is well, explanations about again what it is, and then in user documentation there is a section on building and installing Essentia. Okay, so once we have downloaded, well, there is quite a few dependencies of libraries that are used, like the FFTW or FFmpeg for all the audio in and out, for changing sampling rates, etc., etc. So we have to install all these dependencies. So we will just copy this complete line, and we go there, and we can just we are in our home page, and we just type sudo, and we get all these dependencies that might be needed. So I have to type the password because we're doing it as super user. Okay, and well, I had it installed already, so it just checks and it sees that everything is there. Okay, then if I want to use Python, and I want to use this wrapper for Python, it needs also some Python packages, but in fact I believe these packages were already installed because these are the ones that are used by the SMS tools, the NumPy and the development and NumPy, but we can just make sure that are there. So we just do sudo, and yes, everything is there, so no need to install anything else. Okay, let's continue. Well, there is the instructions for Mac OS X, and now there is the instructions for compiling Essentia. Okay, and this is what we need now. So we have to first configure all the structure of the library in order to be compiled. So we are using this WAV compilation tool, and again we can copy that, and we can go to our Essentia directory. That's here. Okay, that's where we have all our Essentia, and now we again configure all what it needs to be configured, and it will check everything. It checks if everything is there, and it says yes, it's fine, it has been configured. And now we have to compile it, and to compile it we just have to type this compilation instruction. Okay, and this will go through all the directories, all what needs to be compiled, all the C files, and compile them as object files. Okay, so it's building everything, and again this may take quite a bit because it's a pretty large library. So let's stop here because in fact I already have compile all this, so let's stop it, and we can just continue this. So we have compiled it, then we need to install so that all the Python bindings can find all the information, and we can well, there is some you can run some tests, or you can run the Python test, or you can generate the documentation, but the documentation is basically the same documentation that we have here. Okay, so that's done, and then in this directory again we have everything compiled, and we will have the directory where we have all the binaries, and we have everything else already ready to be used. Now we can go back to the documentation and start looking at some documentation for actually using Essentia. So in here there is some tutorials, and the one I recommend is this Python tutorial for beginners. So this is a tutorial that explains how to use Python as a way to call all these Essentia algorithms. So if you go through that, you will see pieces of code that you can basically copy, and by following that you will be able to do some analysis of some sounds. But let's do our own example. So in this text file, I have a piece of code that is basically the one that I use in the theory lecture, that I use to compute the MFCCs. So in fact, you can see this code exactly in the plots from the lectures. But now let's explain what it is, and so that you can actually do it yourself. So it's a Python file that has the standard import packages, the NumPy, the Matplotlib, and the one that now is specific for Essentia is this one. So the Essentia has been compiled, so Python will be able to find this package. We are not importing the whole Essentia, we are just importing one of the packages within Essentia, which is what we call the standard package. There is also another package which is meant to be more efficient for streaming, is the streaming package, but we are not going to use that. We're going to use this more standard package. Okay, and then well, we have some initialization of some variables that will be used for the analysis. We have seen all that, so no need to now to talk about that. The core of Essentia starts now here, in which we are initializing the algorithms that we will be using. Essentia is being written in C++, so it's a collection of classes. Every algorithm is a class, and this is in the sort of object-oriented approach. So in order to use an algorithm, we first have to instantiate the algorithm and give it a name. So here we are instantiating the class spectrum. Okay, we instantiate it with initialization, the size of the FFT, size n, which we have here declared as 1024. And now the variable spectrum has an instance of the spectrum. And we do the same thing for windowing. So there is an algorithm for windowing in Essentia, and we initialize it with a given window size and a given type. And therefore window now is an instance of this windowing algorithm. And again, the same thing for the MFCC algorithm. The MFCC algorithm can be initialized with different parameters, and here we initialize with the number of coefficients that we will be using and the size of the spectrum that will be required. So these MFCCs are now the instance of this algorithm. And one very, very useful set of tools from Essentia is the way to read audio files. In this case, we're using an algorithm called Monoloader, and this is an algorithm that accepts any type of file format, or at least a wide variety of file formats, and then by specifying the sampling rate, it returns a mono file, independently if it was a stereo or even more channels. It returns a mono file, it returns it with the sampling rate that we specify, and it returns it as a set of samples. So X is our array of samples of the input sound. Okay, then we initialize the output array or matrix where we will store the coefficients, and the core of the computation comes now. Okay, so we will be iterating over the sound, computing the spectrum, windowing, and then computing the MFCCs. And in Essentia is amazingly compact. With these 4 lines, we are able to do all that. So one of the core algorithms here is the frame generator. This is an algorithm that automatically iterates over the array X with a given frame size, with a given hop size, and also there is several parameters of how we actually place these windows in the sound. And then this returns then frame, Okay, frame will keep having the samples of that particular frame that we have chosen. So now frame will keep having the different values of our frame, and therefore the window here now will accept the frame, and then we can put it within the spectrum automatically. So okay, so the spectrum will be computed from the windowed frame signal, and MX spectrum returns just the magnitude spectrum, and then this is what it is, the positive magnitude spectrum of this particular frame. And now we can compute the MFCCs. So the MFCCs is again now is this object that accepts the array of magnitude values, and it returns both the coefficients, and also in fact it returns the bands of the MFCCs if we want to use that. But for us, what we are interested is in the coefficients. And since this is being computed at every frame, we need to append to an existing, the initialize to the empty array, and then it will keep appending and create a matrix for that. And then finally, in order to be able to visualize with plots, or to be able to pass to something else, it's good to convert to a NumPy array, so that we can have all the NumPy possibilities to handle that. So now if we go to the directory where this file is, and I believe is in SMS Tools workspace. Okay, so here I have the mfcc.py, and I start with IPython, with Pylab if I want to use the matplotlib automatically. Okay, and now I basically can execute this file. So I can just run an mfccs.py, and this will have computed the MFCCs. So now if we type MFCCs, this is this array, this matrix of all the coefficients at every frame throughout the sound. So in fact now if I do pcolor_mesh, this plotting function of matplotlib, and I give it the MFCCs, it will show the coefficients that it has computed. So here we see it horizontally as the coefficients, the 12 coefficients, with the 0, and then here is the frame location. So this blue line is the 0th coefficient, then we have the first, etc., etc. So that's pretty good, pretty useful. And in order to understand how to call any of these algorithms, what we have to do is to go to the Essentia documentation and go to the algorithm section. There is the algorithm reference, and in here you will see all the algorithms that Essentia has. Okay. Okay, so here we have, as I mentioned, we have two packages in Essentia. One is the standard algorithm, the standard package, so that's the one we're using, and the other is the streaming one. So in here, in the standard one, we have all the algorithms that are currently implemented in Essentia. And for example, if we go to any of the ones that we were talking about, for example, the windowing one, we just go here, and it gives me the input, output, and the parameters that this function accepts. And also, very importantly, it gives us a link to where this algorithm comes from, or what we use as the implementation for this version of this algorithm. And of course, you can find all of them here. That's pretty good. Now let's go back to the documentation and talk about something else, another feature of Essentia. We have been talking about the algorithms that are included in Essentia and that we can use and write Python wrappers to call them. But there's also the idea of complete extractors. So sort of extractors that have been developed in a way that are useful for some particular applications and that extract a whole bunch of things. So extract a whole bunch of these features, and then we have a binary, quite efficient code that can be used. So for example, these are some of the extractors that are already available in Essentia, and there is one that is in fact this streaming extractor Freesound. And this is the extractor that Freesound uses to extract low level and other type of features from every single sound, and that then is the core of this similarity engine that we showed. And all these extractors are in this build source examples directory of Essentia. So if we go to the file browser, this is the Essentia directory, and we go to build, we go to source, src, and examples. Okay, and here we have a whole bunch of extractors, in fact more than the ones that are in the documentation. So these have been already compiled, and we can just use them. So here there is a binary of the streaming extractor Freesound, and we can just copy it. And if we go to the directory where we work from, the SMS Tools workspace, I already in fact have this binary there, the streaming extractor Freesound, and I can just then use it. I can just copy it, okay, and I can execute it. And I can give as input the name of a sound. So here the sounds are in the sounds directory. So sounds, and maybe let's take the sound of rain. Okay, rain.wav. Maybe let's make it so that we see it better. And then we put an output file. Let's just give it the name of rain. Okay, now we execute it. And that's it. It went very quick. So it created two files. It created a JSON file and a YAML file that are the files that include all the results of the analysis. So if we now go to the editor and open this file, for example, the JSON file, this is a particular format that is quite standard, and in which we have all what we have extracted from this rain sound. And well, there is a lot of numbers, but it's pretty good information for a lot of the things that we'll be talking about. Even it attempted to extract the keys of this rain sound throughout the duration of the sound. But anyway, we will be talking more about this in the next programming class of how to use this. Okay, so now if we go back to the documentation, here we see other extractors that are going to be quite useful and we will be talking about. One is this streaming extractor music, and this will be very much useful for analyzing pieces of music. And we'll talk about that next week. And in fact, this is the one that Acoustic Brains, which is an initiative that we started recently, uses to automatically extract descriptors from music. And that's all I wanted to say. So let's go back here. So we made an introduction to Essentia, and we were able to download and compile Essentia from GitHub. And that in Linux is quite easy, it's quite straightforward. And we talk quite a few things about the features of Essentia, what we can do. And we then ended by talking about the extractor that Freesound uses, and that can be used to generate a whole bunch of descriptors of all the sounds. and then we will be able to use for quite a lot of things. So that was all. Hopefully you got a little bit of a very introductory view to Essentia. That's a quite complex library, and it can be quite complicated to use in terms of all the features that it has, but it has an easy way in, and so we can start using it with simple examples, and we will see in the next programming lecture how powerful it is for doing some interesting sound description and describing collections of sounds. So thank you very much, and I will see you next class. Bye bye.